For our next story, we're taking a little break from politics and talking about something everyone loves, animals.
Yay!
This piece truly sounds like it was taken out of the pages of a sci-fi novel. Honestly, the more we learned about it, the more it sounded like Jurassic Park.
In new research, scientists propose building a vault to store animal DNA on the moon. The goal is to safeguard endangered species by storing their genetic material in a safe, protected place in case they go extinct on Earth.
And they think the perfect place is on the moon in something called a lunar biorepository, because the polar regions of the moon are never exposed to sunlight and reach temperatures as low as negative 320 degrees.
It's so interesting. We spoke to the lead researcher on the proposal, Smithsonian scientist Dr. Mary Hagedorn.
There's no place on Earth that's cold enough consistently, and the moon is cold enough, but in just open space, you risk radiation damage. And so by going to the moon and burying the samples on the moon, we could still get the benefits of the cold temperature of space, but the protection against radiation. We wanted to be able to create a biorepository that was not going to be susceptible to climate change or to social unrest or wars.
Biorepositories are basically just libraries that store biosamples for research, and already there are biorepositories for preservation all over the world that store unique seeds.
The most famous is the Global Seed Vault on Svalbard, Norway, that stores 1.3 million seed samples deep in the frozen Arctic Circle in case there's anything happens to food production or crop production. And the seed vault was actually the main inspiration for the lunar biorepository idea.
Back when Russia invaded Ukraine in 2022, underground seed vaults on Ukraine's battlefields were bombed, and tens of thousands of seed samples that were a part of Ukraine's national seed repository were destroyed.
Ugh, it's such a loss, and it proves how valuable biorepositories are, because that's why Russia targeted it.
For the lunar biorepository, on the other hand, the team of scientists are focusing on all different kinds of animals, like threatened and endangered animals like African elephants, great cats, and green sea turtles. And this was interesting. Animals that can improve their environments, like beavers, earthworms, woodpeckers, and even coral.
It's giving Noah's Ark. They'd also preserve pollinators because they support food production, so like bees and moths and bats, and animals that are disproportionately impacted by climate change, like monarch butterflies and polar bears.
And preserving animal DNA is also a lot simpler than we thought. We thought it would be collecting tissue and all of these different kinds of organs.
Sperm and eggs.
Yeah, but apparently it's just scraping off a bunch of skin cells.
And for all you cryo bros, the skin cells are then frozen through a specific process called cryopreservation, which Dr. Hagedorn is actually an expert in.
So for the non-scientists out there, can you explain what cryopreservation is and how that works?
Many people around the world have engaged in cryopreservation because it's the same thing that we use during human fertility techniques. So many people have gone and had sperm frozen or eggs frozen or embryos frozen, and then they're held at liquid nitrogen temperature, which is minus 200 degrees Celsius. Or 20 times colder than, many times colder than your freezer at home, until that person or that family wants to use them. And they can stay in that frozen but alive state, theoretically, for 1,000 years.
And what is the process to get the cells that you need?
It's very simple, very, very simple. And that's the beauty of this biorepository, is that it's just skin cells. We would take a tiny little skin punch, put it in a vial, and then what we do is we extract cells from the bottom of the layer of skin. It's called the basement layer, kind of like the basement in your house. And those are called fibroblast cells. And those cells can be turned into stem cells. And they're very, very powerful. And those stem cells can then be transformed into eggs and sperm. And so in the future, we will be able to recreate organisms just from those fibroblast cells.
It's honestly just so fun to do stories on such out of the box, creative, cool science, because genetic preservation obviously sounds so boring, but they're sending animal DNA samples to craters on the moon. It's crazy that we can even do that.
It really is. And everybody loves animals. And I think not only the potential, but the fact that animals are already dying out is one of the strongest arguments to make to why someone should care about climate change.
Whatever works to get through to people.
We'll take it. Now, the idea of sending animal DNA to space might sound out of this world, pun intended. But people might not know space technology already plays an important role in wildlife conservation. NASA satellites are key to tracking animal habitats, which is crucial to preserving endangered species.
Yeah, for example, satellites have identified large stretches of land for tiger habitats that have lost 93% of their historic range on Earth.
And NASA satellites track elephants' movements, like where do they eat, where do they sleep, what watering hole do they use, so that they can steer land developers away from those areas.
They can also document areas of deforestation and help researchers map out areas for high priority animals like jaguars. But obviously, this lunar biorepository is a bit more far-fetched, so it'll need more funding and testing before it can become a reality.
Even what the genetic material will be housed in on the moon will take a lot of trial and fine tuning. I mean, Dr. Hagedorn told us about the super high-tech box that they're considering storing these samples in that has like sensors on all the sides to detect radiation.
The box is super small, can only hold up to like 8 soda cans, but it costs $1.5 million per kilogram to send things to the moon. And they also hope in the future to send robots up with the box so that they can like dig up holes on the moon to put the box in.
Which makes sense why Dr. Hagedorn said the biggest challenge facing this lunar biorepository idea is money, because sending up so many samples is going to add up.
But excitingly, the first major step to moving this plan forward has actually been approved. So in September 2025, so next year, this team of scientists will launch the box to the moon as a part of Astrobotic's Griffin mission, which will land on the lunar South Pole.
Which is actually super cool they're a part of that mission, because it's the largest lunar lander since the famous Apollo lunar module. And Dr. Hagedorn really put in perspective how important biorepositories will be as climate change continues and sadly animals die out.
Yeah, we've seen flooding and extremely high temperatures and major hurricanes this season. So the thought of losing all of these species isn't some weird hypothesis. It's happening right now.
No, for real. Hurricanes are already so severe they're going off the current scale, and it will only continue to get worse and impact more animals.
Like 100 years from now, a single cell that's, well preserved might be able to completely, revitalize a species. So there are many places that we're starting to run out of time. We need to have biorepositories that are secure. We need to have biorepositories that are inclusive of a lot of different things for our children, our grandchildren, their great-grandchildren. And I think the Earth is very forgiving, but at some point it starts to react. And I think some of these storms and things like that are a consequence of our behavior.